Yeah, welcome to another session of the probability in statistics. So in this, let me continue with some more problems on the basic probability. Yeah, so let me take some more problems. All are the previous gate questions only. Yeah, note down the question: 4 red balls, 4 green balls, and 4 blue balls are put in a box. 3 balls are pulled out. 3 balls are pulled out of the box. 3 balls are pulled out of the box at random, one after another, without replacement. Yeah, the probability that all the three balls are red is. The probability that all the 3 balls are red is option A 1/72, B 1/55, C 1/36, D 1/27. This is the question. So I already told you that the questions they will ask you in such a case. Yeah. So here if you observe, read the question properly. 4 red balls, 4 green balls and 4 blue balls are kept in a box. 3 balls are pulled out, one after the another without replacement. So they taken what outside. That's all. Am I right or not? So out of which all the 3 balls, the probability that all the 3 balls must be a red, they are asking. Am I right or not? So usually how you people will do it as probability. Yeah, probability that all the 3 balls are red. Probability that all the 3 balls are red is, so usually one of the case is what you can go the thing with respect to what our case. So if you observe properly here, if I take an urn or a box, here they given you what the box only they had given. So here which is what 4 red balls and 4 green balls and 4 blue balls. Total 12 balls are there. Am I right or not? So out of which they selected 3 things. So the 3 also, all the things will happen with respect to red. So hence directly you can go with respect to what either 4C3 divided by what. So the number of probable case is nothing but what 4C3 divided by what total will be what 12 C3 will be happening. So hence I think if you simplify it as you people will have it as what 4 divided by 220 will be there. You will have an answer of what 1 divided by 55. So this is one of the case you can do directly. Right, the same case you can do it as directly. All the 3 balls. See, this is R. This is one of the case directly you can do it as, or else you can go with respect to what 3 balls they pulled out. All the 3 balls must be what red they are asking. Am I right or not? So that also I already told you that. So total 4 red balls are there, out of which 4 balls, total 12 balls is there. 4 like that. So if you are taking this one 4 divided by 12 so 1 ball I kept outside. So then remaining will be what 3 divided by 11 will be there. Then remaining will be what 2 divided by 10 will be there. Am I right or not? So if you simplify it, you will have it as what? If you simplify it, you will have it as what check it out. You will if you simplify it, you will have it as what check it out. If you simplify, you will have it as 4 is 12, 12 2 is 24, I think so. 24 divided by 1320. Again, if you simplify it as, you will have an answer of what 1 divided by 55 only you will have it as. So this is the answer. So which option Option B is the right answer for this. Option B is the right answer. Clear with my point? So that is how you people have to solve it, which is one of the previous gate question. Right? Yeah. Next, in the same model, can you solve one more problem? Yeah. Try to do that. Take it. So probability of a probability, so in between they given up to 1 decimal place, because it is a fill in the blank question, up to 1 decimal place of consecutively picking 3 red balls without replacement from a box containing 5 red balls and one white ball, is dash. This is the question mark. Try to understand. They are asking what? Read the question. Probability of consecutively picking 3 red balls without replacement from a box containing 5 red balls and 1 white ball. That means that they given a box. That box contains what? That box contains what? 5 red balls and 1 white ball. So 5 red balls and 1 white ball. So out of which they are taking it as what? They are taking it as what? 3 balls. So consecutively they are picking outside. Am I right or not? So consecutively if they are picking means what? So you can title directly. So what is that answer? Probability of same case of your earlier case. Probability of what? 3 red balls. Similar case. Whichever the method you feel comfort, that you can go directly. So you will have it as what? Out of 5. So 5C3 divided by total will be what? 6C3, which is nothing but what? You will have it as 1 by 2. That is 0.5. Or you can go with respect to what? First ball will be 3 balls they are taking outside. So that is red required. Am I right or not? Yeah. Out of which, so first you have to take it as what? 5 divided by 6. Then will be what? 4 divided by 5. Next 3 divided by 4. Again if you simplify it as, you will have it as 1 by 2, which is what? 0.5. So your answer will be 0.5. Clear? That is how you have to solve it as. Clear? Understanding what I'm saying there? Yeah. Next. These are all the previous questions only, man. Concentrating much more on that. Right? So next problem. A two-faced fair coin. That I already told. Fair or unbiased. Then biased or unfair coin. Am I right or not? Yeah. A two-faced fair coin has its faces designated as head, that is H, and tail, T. This coin is tossed 3 times in succession to record the following outcomes. That is head, head. If the coin is tossed one more time, the probability in brackets up to 1 decimal place of the probability of obtaining head again given the previous realizations of head, would be dash. This is the question. So try to understand. Maybe question seems to be weak, but answer without putting a pen on paper, you can tell the direct answer. Am I right or not? Yeah, tell me the answer. Yes, ma. Come on, give me the answer for that. So what do people have it as? Yeah, you know that since the coin is what, ma? Fair. Yes, since the coin is, you know that coin is what? Fair, which is also called as what? Unbiased. That means that what? Both the faces are same. So what they're telling is they're having the coin they tossed three times. Three times they got it as what, ma? The head. And one more time they want to toss. Then again they want head. What is the probability of getting that head? So simple question only, nama. Actually it is what? The next outcome will be the independent of what? The next experiment will be independent of the previous outcome or not? Am I right or not? Yes or no? So since the coin is unfair, so that is the outcome of next experiment. Outcome of next experiment will be independent. Independent of outcome of next experiment will be independent of what, ma? Previous outcome. Am I correct or not? Am I correct or not? The previous outcome. So hence directly I can tell it as for the next time getting probability of head is what, ma? 1 by 2, which is 0.5. Am I right or not? Yes or no? So that means that probability remains same. A probability remains same for each toss because this is a fair coin or unbiased toss. Am I right or not? So probability will remain same for the each toss. Clear with my point? Getting what I'm saying there? Yes or no? Yeah, that is how you people will do it as. Right? Yeah. So the answer is 0.5. Next, let me take one more problem. Two coins are tossed simultaneously. Two coins are tossed simultaneously. Two coins are tossed simultaneously. The probability of, that is the probability in brackets up to decimal points accuracy. That is the probability of getting at least one head is dash. This is the question. So two coins are tossed at a time. The probability of getting at least one head, that you know that already I had told you. So two coins are tossed means the sample space, which is a 2 square, that is a 4. The sample space is what, ma? Head, tail, head, and tail will be there. So they are taking it as what? At least one head. So you know directly you can do it as probability of, you have it as what, ma? At least by formula wise you can do it as, that is not a big deal. Yeah, at least one head means what, ma? At least means either one or what, more than one. So either one or more than one means this is one, this is one, this is one. So you'll have it as what, ma? Three things will be there, which is 3 by 4. 3 by 4 value will be what? 0.75. This is the answer. Directly you can do it as. That is how you have to solve the questions. These are all the previous gate questions only, ma. Recent question, 1920 questions. Am I right or not? Yes or no? Yeah. This is one more model actually. This is very good example. Let me take that example. It's a previous question based upon the urn and the different criteria. So let me take that problem. Right. An urn contains, take down the question. An urn or box. An urn contains 5 red balls. An urn contains 5 red balls and 5 black balls. 5 black balls. In the first draw, one ball is picked up. In the first draw, one ball is picked at random. One ball is picked at random and discarded discarded without noticing its color. Without noticing its color, mark. See the question properly. The probability to get a red ball, in the second draw is, option A 1/2, B 4/9, C 5/9, D 6/9. This is the question mark. An army contains 5 red balls. So try to understand the question. Okay. Yeah, an army contains 5 red balls, 5 black balls. In the first draw, 1 ball is picked at random and discarded without noticing its color. Right. So then they are asking that. So they are not asking in the first draw. Then directly they are going with respect to what? The probability that to get a red ball in the second draw. So that means 2 times they draw the ball. Am I right or not? So let me take first one. This army contains what? This army is containing what? This army contains 5 red balls and 5 black balls. Am I right or not? So out of which the first things. So this is an urn. Okay. In this urn, total we are having this one. So this, if I take it as an urn, first draw. So let me take the first one. So what is that first draw? What I told here, in the first draw, 1 ball is picked at random. They don't know the color. Am I right or not? So 1 ball is picked at random and discarded without noticing its color. So that means first let me take the first draw here. Let me take this as my first draw. So in that first draw, I just taken the ball without noticing. See, suppose if I take a red ball, 5 red ball, out of 5, if I take a red ball, I'll have here what the probability 5 divided by total 10 balls will be there. 10C1, which is nothing but what? 5/9. Am I correct or not? Sorry, 5/10, which is 5/10. Similarly, here also we'll have it as what? If it is a black ball, so 5C1 divided by 10C1 I'm taking. So which is nothing but what? 5 divided by 10 I'm taking it as. So this is the thing it happened. From this, what will happen? You just try to take it as if I taken a ball, if I assume the taken ball is a red ball, means what? 1 ball I taken outside. Am I right or not? Without noticing and discarded. They told me that earlier it is without replacement. Here what they are telling, they discarded that one. So that means that they kept outside. So hence, what will be happening? If the first ball is, if I'm assuming that as a red ball, then 1 red ball will go on outside or not. So hence I'll have here what? 4 red balls. Am I correct or not? 4 red balls and I'll have here what? 5 black balls will be there. If I assume that as a red ball. Suppose if I assume this as a black ball, if I taken the first one. So obviously again the same thing will happen or not? Red ball will be 5 and black ball will be what? 4 will be there. Am I correct or not? Yes or no? Yeah, this is the part of this one. Then again I have to go with respect to what? The second draw. So here I have to go with for the second draw. So in the second draw, again what I want to do it as, if I take the second draw, if it is a what? Red ball. If it is a red ball means what? You will have it as what? 4C1 divided by what? 9C1. Here also you will have it as what? Red ball means what? Here you will have 5C1 by 9C1 will be there. So what is the value of this one? Can you tell me what is this value? This value will be what? 4 divided by 9 and this value will be what? 5 divided by 9. So this is the criteria. The same model next one here the taken ball is the taken ball they discarded. Suppose next model they will give you they will the ball what they had taken, then again they will replace it as by that color or that different things. So like that you people have to take it as what? That criteria. So now check it out, the probability. Here I have 2 different cases. So try to understand this properly. See what they told is, they have, I'm again repeating this one. An army contains 5 red balls and 5 black balls. Total 10 balls are there. In the first draw, they taken that ball, they discarded without noticing this color. 1 ball they picked outside, but they did not notice that color. So they discarded. So for that, so let me take in the first draw. So the taken ball, I'm just assuming it as a red ball. If it is so, then I'll have the probability as 5 by 10. If it is a black ball, means you will have again what, 5 by 10 only. Am I right or not? So this they discarded. They told me that what, discarded. If it is a red ball, means one ball will reduce. Am I right or not? In the first draw. So likewise, I got remaining balls. With the remaining balls in the second draw, if I want to get the part of your red, then I have to get that criteria. So now the overall probability in the second draw, so that is probability of that red ball, probability of my red ball. So these two cases I have to substitute it. These two things I have to consider it as. So which is nothing but what, both the cases. In the first draw, 5 by 10 into 4 by 9. Similarly, what, 5 by 10 into 5 by 9 I have to do it as. So based upon these two criteria. Getting what I'm saying here? Are you understanding what I'm saying here? So that is, you'll have it as what, 5 divided by 10 into 4 divided by 9 plus, I'll have it out again, 5 divided by 10 into 5 divided by 9. So if you simplify, you will have it as what, 45 by 90, that is equal to what, 1 divided by 2. This is the answer for that. Clear with my point? Yes or no? So that is how you people have to do it as. Getting what I'm saying here? Yes or no? Are you able to following me there? Yes? Yeah, that is how you people. Yeah, so this is the thing. This is how you people have to solve this one. So if you want, you can take the note point here. So how I got that two different cases. Am I right or not? So in this, you will have to make it as the two different cases that you write down, so that while solving the next problem, you will get an idea. So here there are two different draws are there. So that is the reason why I am representing here. So let me take this one. That is first ball. First ball drawn is red. First ball drawn is red. And second ball drawn is red. So this case is what? That is 5 by 10 into 4 by 9. Then similarly second case again. First ball drawn is black, and if first ball is drawn black and second ball drawn is red, if I am taking, so second ball is that is second ball drawn is red. So which is nothing but what, 5 divided by 10 into 5 by 9. So overall will be the 1 by 2. So that I added these things. So this is how you people have to go with the concept. So based upon that one more, you can check it out. Based upon that one more, you can go with what? Based upon that, you can go with one more problem is there that you can do it as. Let me take that. Can you try that problem? The same example, just they given one just litigation, right? So try that. Just one litigation that. So let me take down. An urn contains 5 red balls and 7 green balls. 5 red balls and 7 green balls. A ball is drawn at random. A ball is drawn at random and its color is noted. The ball is placed back. The ball is placed back into the urn. The ball is placed back into the urn along with another ball of the same color. Along with another ball with the same color. Yeah, the probability of getting a red ball in the next draw is? In the next draw is. This is the question. So try to understand this question properly. 65 by 156. Option B. 67 by 156. C. 79 by 156. D. 89 by 156. So this is the question. So earlier question is the small slight deviation, that's all. Earlier what they done? Previous question is nothing but what ma? The same thing will be there. So one ball is picked at random and discarded without noticing its color. But here in this problem, they taken the ball and they noticed the color, and what they done? What they done ma here? If you observe properly, if you observe an urn contains 5 red balls and 7 green balls ma. A ball is drawn at random and its color is noted. So they taken one ball and they noted its color. Am I right or not? And what they done is the ball is placed back into the urn along with the another ball of the same color. Suppose if they taken the taken ball is red, then what they done? Again they place it back. If they taken green ball, again they place it back the same another ball. They taken one ball, right, and they notice the color and they replaced the same another ball. They replaced with the another ball with the same color. Am I right or not? So here also you have to consider it as 2 draws only, but the case is different. Earlier case is different and this case is different. So let me take this one. So here this urn contains 5 red balls and 7 green balls. So 5 red balls and 7 green balls you are having in the first draw. So this is an urn. So let me take for a first draw. If I take it as a first draw, so what happens in the first draw? If I take on the first draw, this if it is happens. If I take the first ball as, if I take it as a red, if I take it as a green, this one. So you will have it as what? Total 12 balls will be there. So 5C1 divided by 12C1, which is what ma? 5 divided by 12. And here it is nothing but what again? Sorry, if it is a green ball, you will have it as what? 7C1 by 12C1 will be there. So which is nothing but what? 7 divided by 12 will be there. So up to here it is okay. Same as is of your earlier case. But the condition here is, what they done earlier is they discarded the ball. Now they are taking it as what? They noted the color and with another ball they replaced it as. Am I right or not? They did not discard it. Am I right or not here? So now if the ball is red, means one more ball is added. Am I right or not? One more ball is added. That is nothing but what ma? Already 5 red balls will be there. So if it is added means you will have it as what? 6 red balls, and one is nothing but what? 7 green balls will be there. Am I right or not? Yes or no? Yes. Yeah. So this problem is somewhat the deviation from the earlier problem. So here what they done, with the same color another ball they replaced it. Suppose if it is a green ball. So already 7 green balls are there. So which is added with what? One more green ball. So that is 8 green balls you will have it as. So now the rest of the things will be same. So rest of the things will be what ma? Same. So if it is a red ball, if they want, if it is red ball, that is a second draw. If I take it as, if I take this as a second draw, yeah, in the second draw you will have it as what ma? 6 divided by what? 6C 1 divided by total 6 plus 7, 13 will be there. So 13 C1, which gives you what? 6 divided by 13. Similarly this case, so total you will have it as 5 red balls, so which is 5C1 divided by 13 C1, so which is nothing but what? 5 divided by 13 will be there. Am I correct or not? The same criteria earlier problem. So the analysis, so what is the probability of getting a red ball will be what? Probability of getting red ball will be what ma? 5 divided by 12 into 6 divided by 13 plus 7 divided by 12 into 5 divided by 13, which is nothing but what? 65 divided by 156. So this is the answer. If you simplify it as, you will have it as the same answer. So if you want the cases like your earlier problem, write down that cases here. Am I right or not? So note down, that is the probability of drawing a red ball in first draw and a red ball in the second draw. Is 5 by 12 into 6 by 13. This is the first case. Similarly you can go with what? The probability of getting, that is the probability of drawing a green ball in the first draw, and a red ball in the second draw, is 7 by 12 into 5 by 13. So if I add those two things, you will have the answer. Am I right or not? So that is how you people have to do the answer for this problem. So this is very important. So I hope now you got it as. If at all you have any doubts, you can get the clarity. You can ask me, I will give the clarity. Okay, don't get bothered. Yeah. Next problem. 3 fair cubical dice. Next problem. 3 fair cubical dice are thrown simultaneously the probability that all the three dice have the same number of dots on the face showing up is dash in brackets up to third decimal place. This is the question mark. I hope you know that. Maybe this I given you in the note point. If you observe properly this, 3 fair cubical dice. So 3 fair cubical dice is thrown, and that 3 dice will have the same number of dots. Am I right or not? As showing here. So the number of phases in that. So I told you that for n dice, I told you that the probability of getting the same phases. Same phases is nothing but what, that you know, that 6 divided by 6 to the power of n. So now here they are given what, they given what, particularly 3 dices are given. So for the 3 dices you are having what, probability of getting same phases, which is nothing but what, 6 divided by 6 cube. So if you simplify it as, you will have it as what, 1 divided by 36. So the answer for this is what, I think so, 0.027. This is one of the previous gate question. I think gate 17 question it is. Am I right or not? So now you can able to easily solve it. Clear with my point? Yes, ma? Yeah, this is the question. Then similarly, one more question, which is also the easiest one. So let me take down 500 students are taking one or more courses. 500 students are taking one or more courses out of chemistry, physics and mathematics. Chemistry, physics and mathematics. C means chemistry, P means physics and M means mathematics. Registration records indicates course enrollment as follows. Chemistry 329, physics 186, mathematics 295, chemistry and physics 83, chemistry and mathematics 217, physics and mathematics 63. how many students are taking all the three subjects. How many students are taking all the three subjects? Option A 37, B 43, C 47, D 53. So this is the question mark. Simple question. Maybe question seems to be big in size, so that is not a big deal. How I have to solve this one? So try to understand. This is an application of your what ma? The addition theorem for three different events. So 500 students are taking one or more courses out of chemistry, physics, mathematics. Registration record indicates that. So the enrollments, course enrollments. So how many students are taking chemistry? How many students are taking physics, mathematics, and both the cases, chemistry, mathematics, physics, mathematics, and they are asking that how many students are taking all the three subjects. How many students are taking all the three subjects? That is what the particular ideology. Am I right or not? So that is required. So can you tell me what is the probability of that one? So if I take if I take this as a direct case, so let me take I need to calculate the probability of chemistry union physics union mathematics. So this is your addition theorem. Probability of A intersection A union B union C. So if I expand this one, what do people will have it as? Probability of chemistry plus probability of physics plus probability of mathematics. Probability of A plus probability of B plus probability of C. Then next one will be what? Minus what? Probability of chemistry intersection physics minus a probability of what ma? Physics intersection mathematics minus a probability of what? Chemistry intersection mathematics or mathematics intersection chemistry. So plus probability of what? Chemistry intersection mathematics physics intersection mathematics. This is what the criteria. Am I right or not? So now they asked you what ma? How many number of students are taking all the three subjects? That means that this it is required. All the three subjects means what ma? Intersection part you have to calculate as, and the rest of the things they had given. So here this value will be what? This value will be what ma? This is 500. So 500 is equivalent to all the values you can do it as 329 plus 186 plus 295 minus 83 minus 217 minus 663. This you have to calculate it as probability of chemistry intersection, physics intersection, mathematics. You have to calculate it as. So now can you tell me what is that? What is this value? Probability of chemistry intersection, physics intersection, mathematics, which is equivalent to what ma? 500 minus, I think so. If you do this, you will have it as what? 447. So 447. So if I subtract this, you will have it as what ma? 53. So total all the 53 students are taking all the three subjects. This is how you people have to solve that problem. Clear now? Getting what I'm saying here? This is how you have to do it as. Got my point? Got my point now ma? Yeah. So let me take one more problem. So likewise you people have to solve the n number of problems ma. So I'm just giving all these criteria. Then I will give some problems as a homework. Okay. Based upon the conditional probability also they asked you one of the question mark. So that is conditional probability. Take down the probability that a communication system have will have fidelity is 0.81. That is a high fidelity, you can take it as. Will have a high fidelity 0.81. The probability that the system will have both high fidelity and high selectivity. High selectivity is 0.18. Right? The probability that a given system, the probability that a given system, the probability that a given system with high fidelity will have high selectivity. Will have high selectivity is dash. This is the question. Option A 0.181, option B 0.191, C 0.222, D 0.826. 0.826. Okay, this is the question. Yeah, just understand this is an application of your the conditional probability. It's an application of your conditional probability. Maybe terminology is somewhat difficult, high fidelity and high selectivity. So this this terminology will be understood by instrumentation people and communication people, because the subject called as communication, they will have that terminology. Okay, don't get bothered. But remaining people also can do it as, that is not a big deal, right? So you can go through it as. So check it out. What they had given in the problem? What they had given in the problem? Yes, I think they had given a probability of high fidelity. Probability of high fidelity is 0.81 they had given. And similarly, probability of high fidelity intersection probability of what? High selectivity, which is given as what? 0.18. These two things they had given. Am I right or not? Yes or no? Then they are asking that the probability that a given system with a high fidelity will have a high selectivity. So that is high selectivity given high fidelity. Am I right or not? So you know high fidelity. Am I right or not? But you don't know high selectivity. So that unknown terms in terms of your known terms. They are asking what? Probability of high selectivity given high fidelity. So where fidelity known event, where high fidelity is what? The known event, and selectivity unknown event. So unknown event in terms of known events, I am representing it as. So that is called as what? The conditional probability. So apply the conditional probability. Probability of what? High selectivity intersection, high fidelity, or high fidelity intersection means what? Both are same cases. That is not a big deal. So which is having what? This one. So substitute that values directly, you can get the answer or not. Check it out here. What do people will have it as? This is a 0.18 value divided by what? 0.81. So if you do it as, you will have it as a 2 by 9, which is the value of your 0.22. So question seems to be big, but question seems to be what? Big, but it is nothing but what? If you are using your common sense, it is very easiest way. Clear with my point? Yeah. So that is how you people have to solve the problems based upon that criteria. Can you try one more problem? It's a mathematical thing. It's a mathematical thing. Try this. Let me take this problem. Try this one. Capital X and Y are two independent random variables. Two independent random events. It is known that probability of X is equivalent to 0.4 and a probability of X union Y complement is equivalent to 0.7. Right? Then which one of the following is the value of probability of X union Y? Which one of the following is the value of probability of X union Y? So option A 0.7, B 0.5, C 0.4, D 0.3. This is the question. While solving that thing, you have to understand the question properly. They given what? X and Y are the two independent random variables. So independent random variables means what? You know that independent random variables, random events. Yeah, events. Independent events, right? So if it is independent events, what's the probability of A intersection B? What are the probability of A intersection B for independent events? Probability of A into probability of B, that you can write it as. So that is they given some values and they are asking some unknown values. So let me take that criteria. Let me take that one. Since X and Y are what? Independent random events or independent events, that is not a big deal. which is independent events. So you can write it as what? Probability of x intersection y as probability of x into probability of y I can represent it as. Am I right or not? Yeah. So given what they had given there, what they had given ma? Given probability of x union y complement, right? So what is that? If I expand this one, probability of x plus a probability of y complement minus a probability of what? X intersection y complement. Am I right or not? So since x and y are the independent events, I can represent this as what ma? Since if it is a independent events, I can represent this as what? I can represent this as what? That is probability of x plus probability of y complement minus probability of x into probability of what? Y complement I can mention it as. Am I correct or not? Am I correct or not? Because it is an independent event. So it is x union y complement. Am I correct or not? Yeah. Now from this, if I take a probability of x plus a probability of y complement as a common, if I take it as if I take these two things, probability of y as a y complement as a common, I'll have it as what? 1 minus probability of x I can represent as, because I know probability of x, but I don't know what the probability of y complement. Am I right or not? So now can you substitute the values in this? This is your probability of x union y complement. They given in the problem itself, x union y complement value will be what ma? X union y complement value will be what? 0.7, and the probability of x is what? 0.4 plus probability of y complement into 1 minus probability of x is what? 0.4 you will have it as. Am I correct or not? So just simplify it as it's a mathematical thing. 0.7 is equivalent to 0.4. This I can bring over this side now. Yeah, this I can bring it as this side. So this is a 0.7 minus 0.4, which is equivalent to probability of y complement into 1 minus 0.4, which is nothing but what ma? 0.6. What is a 0.7 minus 0.4? You will have it as 0.3, which is probability of y complement into 0.6. Then from this, what is your probability of y complement? Probability of y complement will be what ma? 0.3 divided by 0.6, which is nothing but what? 1 by 2. I can represent as what ma? 0.5. So this is your probability of y complement. Yeah, from this I can calculate what ma? Probability of y. You know that what? Probability of y complement is you are having what? 0.5. Then probability of y you can represent as what? 1 minus probability of y complement. So give me that value here again, which is nothing but what? 1 minus 0.5. This also I can take it as what? 0.5 I can take it as. Am I right or not? Yeah, that you can do it as. Okay. Yes or no? Yeah. Once if you know that, then I need to calculate what ma? I wanted to calculate what? Again, probability of x union y I have to calculate as. Then again same strategy. Probability of x plus probability of y minus probability of x intersection y. Because this a and b are, sorry, x and y are the independent events. This I can represent as what? Probability of x plus probability of y minus probability of x into probability of y. So all the values you know that, substitute it and get me that value. Probability of x is 0.4, probability of y is 0.5 minus probability of x is 0.4 into 0.5 will let us. So if you simplify it as, if you simplify, you will have it as answer as what ma? 0.7. So now the value probability of x union y is equivalent to the value probability of x union y is equivalent to what ma? 0.7. This is the answer for that particular criteria. Understood what I'm saying here? Yeah, that is how you people have to solve the problems. Clear? Getting what I'm saying? So likewise, you need to solve the things ma. Okay. Yeah, and one more. So likewise, you people have to solve the things. Can you try this problem? It is also good example. Yeah, given set A is equivalent to, given set A is 2, 3, 4, 5 and set B is equivalent to 11, 12, 13, 14, 15. Right? Yeah. Two numbers selected randomly. Two numbers selected randomly one from each set. One from each set. What is the probability that? What is the probability that the sum of two numbers, equals to 16? What is the probability that the sum of two numbers equivalent to 16? Option A 0.2, B 0.25, C 0.3, D 0.33. This is the question. That is the question. Now tell me that what they are asking. What they are asking, ma? They had given two sets. That is a set A is 2, 3, 4, 5 and set B is 11, 12, 13, 14, 15. Am I right or not? So two numbers are selected randomly from each set. So and they are asking the sum of two numbers. The sum of two numbers equal to 16. Okay, this is they are asking. The sum of two numbers are 16. Am I right or not? Are you getting what I'm saying? Yeah, that is how you people have to do it. So what is this one, ma? Sum of two numbers is nothing but what? 16 is required. Yes or no? So how you people will do it as? Sum of two numbers are 16 means what, ma? Sum of two numbers are 16 means what? Yes, these two numbers. So favorable cases. Let me take the favorable cases. What are the favorable cases here? Sum must be 16. So which is 2, 14 I can take it as, check it out. Then 3, 13 I can do it as. Then 4, 12 I can do it as. Then 5, 11 I can do it as. Am I right or not? Is there any other possible cases you will have? No. Sum must be 16. These are the favorable cases. Am I right or not? Then total number of cases will be what, ma? Total number of cases will be what? Which is 4 into 5, that is what? 20. So now the probability of getting what? What is that? The probability of what? Sum of two numbers. Sum of two numbers equals to 16 is equal to what? My favorable case is what? 4 divided by 20, which is what? 1 by 5. The answer is 0.22. Clear? Which is 0.22. Understanding? Yeah, that is how you people have to do it. Right? Clear? Clear or not? Yeah. And one more problem. Take down. That is next one problem. Ram and Ramesh appeared. Ram and Ramesh appeared in an interview. For two vacancies. In the same department. For two vacancies in the same department, the probability of Ram's selection is 1 by 6 and Ramesh is 1 by 8. Then what is the probability that only one of them will be selected? Only one of them will be selected. This is the question mark. So options are 47 by 48, B 1 by 4, B 1 by 4, C 13 by 48, D 35 by 48. This is the question. Okay, yeah, read the question properly and give me the answer for that. So Ram and Ramesh are appearing what? Ram and Ramesh are appeared in an interview. Okay, so for the two vacancies in the same department, then they given the probability of Ram selection is 1 by 6 and Ramesh is 1 by 8 more. Right, then what is the probability that only one of them that I already told you, only once is nothing but what? That I can represent it as what ma? So they given what? A probability of only once, only one of them, so which is nothing but what? Probability of A delta B, that is, so which I can represent as what? Probability of what? A intersection B complement plus probability of A complement intersection B. I have to do it as, am I correct or not? This is what that thing na? Yeah, yes or no? So where A is, you can take it as A means Ram and B means you take it as what ma? Ramesh. In the problem itself they provided you that probability of getting Ram, probability of getting selecting Ram is what ma? 1 by 6 they had given. From this you can carry it as what ma? Probability of A complement is nothing but what? 1 minus probability of A. So which is nothing but what? 1 minus 1 by 6. This is nothing but what? 5 by 6 na? Similarly, what is the probability of Ram B Ramesh, which is nothing but what? 1 by 8. From this also you can calculate what? Probability of B complement, which is nothing but what? 1 minus probability of B, that is 1 minus 1 by 8, which is nothing but what ma? 7 by 8. Yes or no? So now only once means what? That is probability of A delta B, which is equivalent to what? Probability of A intersection B complement plus a probability of A complement intersection B. Again, if you check it out, in the same sample space, because in the same department they told that. Am I right or not? Which is what ma? Same department they told. So if it is same department means what? Occurrence of A does not depend upon the occurrence of B. So hence these two events are what ma? Which is what? It is a mutually exclusive events or not? Sorry. Sorry. This is not mutually independent events ma. Sorry. See, here we are having what? For the same department only they are taking. Same department only they are taking, but two different vacancies. First vacancy and the other vacancies. Am I right or not? So for two vacancies they are taking. So hence A and B are what ma? A and B are what? A and B are what? What? Independent events. Am I right or not? A and B are what? Which is a independent events. So for independent events, what you people are having here? It is independent event means what? Probability of A into probability of what? B complement plus probability of A complement into probability of B I can do it as. So now what I'll get as here? Substitute, because you know all the values. You know all the values. What is your probability of A ma? Probability of A is 1 by 6. Next probability of B complement is 7 by 8. Then probability of A complement is 5 by 6. Then probability of B is what? 1 by 8. So if you simplify it as, you will have it as what ma? Check it out. If you simplify, you will have the answer as what? 1 by 4. You can cross verify it as. If you simplify that, you will have an answer of what? 5 by 6. Sorry, 1 by 4. That is the thing. Okay. Got my point? Yeah. Next, one more problem. Next problem. If probability of X is 1 by 4, probability of Y is 1 by 3, and probability of X intersection Y is equivalent to 1 by 12, then the value of probability of Y given X is, probability of Y given X is option A 1 by 4, B 4 by 25, C 1 by 3, D 29 by 30. Which is a question. So they asked you what ma? Probability of Y given X. It's a conditional probability ma. That you can represent as what? Probability of X intersection Y or Y intersection X. That is not a big deal. Divided by probability of X. This you people have to do it as. That's a simple thing. simple substitution method. What is your probability of x intersection y, ma? 1 divided by 12 divided by x is what? 1 divided by 4. So if you simplify it, you will have it as what? The answer is 1 by 3. It's a simple question or not? This is the simple question. You can do it as. Clear? Understood all of you? What I'm saying? Is it clear or not? Yeah. Next problem. Next problem. It is a theoretical statement. Suppose A and B are the two independent events. Suppose A and B are two independent events with probabilities probability of A is not equivalent to 0 and probability of B is not equivalent to 0. Let A bar and B bar be their complements. Which of the following statements is false? Which of the following statements is false? That is a question. Okay, the given A and B are independent events. So option A, a probability of A intersection B is equivalent to probability of A into probability of B. Then option B, probability of A given B is equivalent to a probability of A. Then C, probability of A union B is equivalent to probability of A plus a probability of B. And option D, probability of A bar intersection B bar is equivalent to probability of A bar into probability of B bar. So this is the question, and they are asking which one of the following statement is false? Which one of the following statement is false? That is they are asking. So try to do that. Come on, try to solve that. Come on, try to solve this. Yeah. So in order to understand this, let me take this one. The question they had given in that is what? Suppose A and B are the two independent events. So A and B are the two independent events such that with their probabilities, probability of A is not equal to 0 and probability of B is not equal to 0. Then which statement is false they are asking. So which statement is false? If it is a independent events, that you know that probability of A intersection B is what? A and B are independent means what? Occurrence of A does not depend upon occurrence of the B in the different sample space. So hence option A is correct. It's a correct statement. Am I right or not? Yeah. Then similarly, what is your probability of A intersection B? You can take it as first statement is directly you can do it as option B is nothing but what? Probability of A given B is nothing but what? Usually probability of A intersection B divided by probability of B will be there. So if it is independent events, you can represent as what? Probability of A into probability of B divided by probability of B. So this answer is what? Probability of A. So this statement is also correct. So statement B is also correct. When it comes to the part of the third statement, which is also what? Correct statement. Sorry, fourth statement is correct only. Come to the part of your third statement, which is nothing but what? Probability of A union B. Probability of A union B, usually how you have to represent as this is a addition theorem, which is nothing but what? Probability of A plus probability of B minus a probability of what? A intersection B. Am I right or not? So what is your probability of A intersection B? Is it possible always? Because probability of A intersection B is nothing but what? Probability of A into probability of B. But that should be is not equivalent to 0. Why? That should be not equivalent to 0. Why? Since it is what? They given you what? The probability is probability of A is not equivalent to 0 and probability of B is not equivalent to 0. So then only this is 1. So this statement is what ma? This is not equivalent to this one. So actually this is this one. Probability of A union B is equivalent to probability of A plus probability of B minus probability of A intersection B. So hence this statement is wrong. So this statement is what ma? Third statement will be the false. So answer is this one. Remaining all are what? This is true. This is also true. And this is also true. The last statement is, third statement is false. Am I right or not? Getting what I'm saying here? Yes? Yes or no? Yeah, that is how you people have to do that thing. So can you try one more problem? Yes? Yeah, can you try this problem? Let me take this. It is also a very interesting one, which is also interesting one. Consider a die. Consider a die with the property. Consider a die with the property that the probability of a face with n dots showing up is proportional to n. Okay, the probability of the face with three dots showing up is dash. This is the question. Try to understand the question properly here. Nothing is there. So see, consider a die with the property that the probability of a face with n dots, suppose if it is having n dots, is proportional to your n. Suppose if I am having 1 dot, it is equivalent to proportional to 1 dot. 2 dots means proportional to 2. 3 dots means proportional to 3. Am I right or not? So let me take this one. Let probability of occurrence of 1 dot is that 1 dot I am taking it as what ma? P I am taking it as. So if I write total probability, what's the total probability? If I write the total probability, which is equivalent to 1 ma. Yeah, what's the total probability here? For 1 dot means 1p. For 2 dots means 2p. If I throw a dice, sample space, which is nothing but what? 3p. Next, which is nothing but what ma? 4p. Next one, 5p, which is 6p, which is equivalent to what? 1 or not? Yeah. If I add all those things, the value of your p, you will get it as what? 1 by 21. But they are asking what this is for one value. Suppose the occurrence of what they asked you what in the problem, what? If I take this one, hence the probability of occurrence of 3 dots is, which is equivalent to what? 3 into p. So that is 3 into 1 by 21. So which is, you will have it as what? 1 by 7. This is the answer. That's all. Got my point? So that is how you people have to solve the problems based upon your what ma? These things. So let me give you the problems based upon the homework ma. I'll just give you the homework problems so that you can have an idea. Just these things you already done, I think. So based upon these models I already covered. If at all you are finding any problem, you just ask me, I will give you the clarity. So homework problems, try to solve this one. A box contains 4 red balls and 6 black balls. A box contains 4 red balls and 6 black balls. 3 balls are selected. 3 balls are selected randomly. 3 balls are selected randomly from the box, one after another. one after another without replacement. Without replacement. The probability that the selected set contains one red ball and two black balls is dash, which is 1 by 20, B 1 by 12, C 3 by 10 and D 1 by 12. So they are asking what? It's a set of simple criteria, nothing more than that here. So that box contains 4 red balls and 6 black balls. 3 balls are pulled out. Am I right or not? So 3 balls are selected randomly from the box one after the another without replacement. The probability of getting the selected set contains 1 red ball and 2 black balls. 2 black balls they are asking. So directly you can tell it as what? Probability of 1 red intersection set of means. So 2 black balls. So directly you can represent as what? Directly you can represent as what here? 1 red ball out of what? That is 4 red balls, which is 4C1 divided into total 6C2. Am I right or not? Divided by, you will have it as what? Total balls will be 10C2. Am I right? So you will have it as what, ma? 4 into 5 divided by, you can check it out, cross verify it as. So you will have the answer as what? 1 by 2. Clear? Are you getting what I'm saying? Understood? Yeah. Then one more problem. I asked actually this as a homework, but myself itself solved. Yeah. Next problem. There are two containers. There are two containers with one containing 4 red balls, and 3 green balls. 3 green balls, and the other containing 3 blue balls and 4 green balls. One ball is drawn at random. From each container. The probability that one of the balls is red and other is blue will be dash. Option A, 1 is 1 by 7, B 9 by 49, C 12 by 49, and D 3 by 7. This is also thing. One is red and other is what, ma? Blue. Am I right or not? So two things will be there. Directly you can solve it as same as your earlier problem only. Same as your earlier problem, you can solve it as nothing there here. Check it out. Probability of one is red and other is blue. Directly you can do it as, yeah, which is probability of 1 red intersection 1 blue out of that thing. So you are having what more? Red means what? 4. So which is 4C1, that is 4 from 7. That is one thing. Second one, blue. Blue means what? In second one you are having 3 things. 3 out of 7. So which is 3 divided by 7. Directly you can do it as simple criteria, which is 12 divided by 49. Am I right or not? So simple problems. These are all the simple problems. Okay, that you can solve it, Nama. So this is about the basic problems. This is about the basic problems of your what? The probability concept. Okay, the probability concept. So if time permits, I'll solve some more problems, and you try to practice more number of problems, ma. We try to practice the more number of problems. Okay, so this is about the particular case. In the next session, we'll start with the Bayes theorem and the total probability. These are all the basic probabilities, ma. If you are be perfect with these criteria, I will give you the next things. The rest of the criteria all are what? Very easiest criteria, easiest manner. Clear with my point? So please let me take these criteria. So these are the some of the basic problems. So in the next session, I'll start with what? The total probability as well as your Bayes theorem. Then some of the problems based upon that. Then we'll go with what? The distribution as well as your density functions. Then that ends your probability concept. Then the other one will be what, ma? The statistics part. Okay, yeah. So thank you. We will meet in the next session, right? We will meet in the next session. Okay, thank you.